Hey guys, so we're going to continue learning on systems of equations, and today I am going to talk about solving a system of equations using substitution. Substitution is actually one of our algebraic ways of solving a system. So last week we learned how to solve a system by graphing. So you would graph the two lines, and where they intersected would be your solution. So now we're going to be solving systems algebraically, and substitution is just the first form. So quick reminder, a system of equations is two or more equations with the same variables. And at least for the purpose of 8th grade and probably algebra 1, our common variables that they're going to be the same are x and y. So the substitution method is good for solving a system of equations when one of the equations has a variable that is isolated, or if either x or y have a coefficient of 1, and most of the time that 1 is going to be invisible. So I'm just going to go ahead and write the system, and actually I'll just type it up. So this system, the two equations, is going to be 3x plus y equals 6, and then the second equation is going to be x equals negative y plus 4. So as we can see here, the second equation already has the x that is isolated on the left side. So this is where substitution would be good to use. So I'm going to go ahead and write the equation down over here just to kind of explain what we're going to do. So what we're going to do is, since x is negative y plus 4, basically x equals all of this. Negative y plus 4. So since x does equal that, all of this is going to be the replacement for x. So just to kind of take it back to like 6th grade, when you guys had something like this, x plus 1 equals, I don't know, 5. This is a simple enough equation. X obviously has to be 4, so we could replace x with 4. So 4 plus 1 equals 5, and then we just show that that works. So substitution is you're just replacing the variable with a number. So that's like 6th and 7th grade. But now as an 8th grader and future Algebra 1 student, our substitute is going to be something a little bit more complicated than just a number. Like we see here, all of this is going to be the substitute for x. So we're going to replace x with negative y plus 4. And in order to do that, we're actually going to use the first equation. So I am going to use this substitute, negative y plus 4, and I'm going to go and substitute it in for x in that equation. So I'll go ahead and just change the color and say 3x plus y equals 6. And again, this substitute is going to go in for x. So right here where this is an x, I am going to replace it with negative y plus 4. And in order to do that, since there's actually two things going on, this means 3 times x. When they're together, they're being multiplied. So I am going to put all of this, negative y plus 4, in parentheses. So just, this parentheses also means to multiply. So that's what I'm doing there. So then plus y equals 6. So everything basically in the first equation is staying the same, except I replaced x with what it equals, because x equals negative y plus 4. And then now this is where we could actually use the page 14, I should say, of our binder. It just has the steps of solving equations with one variable, because now that I've replaced x in the first equation, I literally just have the equation with y's, which means since I don't have an x anymore because I replaced it, I can now solve for y. So we're going to follow the steps on page 14 to solve this equation for y. So the very first step that we have on page 14 is distribute if there's parentheses, which obviously we see here. So we're going to go ahead and distribute the 3. So 3 times negative y, and then 3 times 4. So 3 times negative y is negative 3y, and then plus, and then 3 times 4 is 12. And then we just bring everything down. So plus y equals 6. And then the next step is to simplify both sides of the equation by combining like terms. So as we can see here, we have the like terms of negative 3y and y. So I'm going to go ahead and combine those. And then we get negative 2y plus 12, because then we just bring down that 12, equals 6. And now this is actually a 7th grade two-step equation. So we're going to get rid of this constant with the negative 2y, this plus 12. And in order to do that, we're going to go ahead and subtract 12 to both sides. And then we bring down this negative 2y, and then 12 minus 12, they cancel out. Then we bring down our equal sign. And now 6 minus 12 is actually negative 6. And now the final step to get y by itself is to get rid of this negative 2. Since they're together, they're being multiplied. So we got to do the opposite, which is division. So I'm going to divide both sides by negative 2. And now we see that negative 2 divided by negative 2 makes 1. And we don't usually put the 1, it's just y, because 1y is just y. So I'll just go ahead and erase the 1. And then on the other side, negative 6 divided by negative 2 makes positive 3. So that tells me now that y is 3. And now, since I already have at least one of the variables, it should be easier to solve for x. Because you guys have to remember that a system has 2 variables most of the time. And in our case, they're going to be x and y. So I know what y is. I know that y is 3. So now I have to figure out what x is. And I could use this. Y is 3. And if you notice, the second equation that already had x equals negative y plus 4, x was already isolated. That one would be a good equation to use to solve for x, just because it's practically already done, because we already have x equals. So I'm going to now plug in my number for y. So we had already solved it. Y is 3. So now I'm going to go in here, and now I'm going to replace y, because y is 3, with the 3. So now I'm going to put the whole equation the same, x equals, and then there's this negative, and y is 3, so I'm going to plug in the 3. So now it actually becomes negative 3, and then plus 4. And when you solve negative 3 plus 4, that makes a positive 1. So then that tells me that x is 1. So now I know the two variables, x is 1 and y is 3. And if you guys remember when we were solving a system of equations using by graphing, we would write the solution as a point. So I'm going to write my solution as a point x comma y. And since x is 1 and y is 3, my solution is 1 comma 3. Now I'm going to show you guys how to check your answer. You guys can go back and rewind the video to if you need to get caught up. I'm going to show you guys how to check the answer. So again, the answer was 1 comma 3. So I'm going to use both equations. I'm going to go ahead and use blue for the first equation. So the first equation is 3x plus y equals 6. And I'm going to actually replace x and y with these numbers. So for x, I'm going to replace it with 1. And then for y, I'm going to replace it with 3. Now, you guys have to remember that this means 3 times x, so that actually means 3 times 1, and then plus the y, which is 3, will equal 6. And what I'm doing right now is I'm just checking my answer to make sure that it does balance out both equations. So 3 times 1 is 3, and then 3 plus 3 is obviously equal to 6. So it does balance out the first equation. Now, the second equation, I'm going to use like a purplish color, is x equals negative y plus 4. And again, I am going to replace x with 1 and y with 3. So x equals, and there was that negative in front of the y, so make sure you keep it there, So now it's negative 3 plus 4. And then negative 3 plus 4 is actually equal to 1. So when x is 1 and y is 3, it balances out both equations. The first equation balances out to 6 equals 6, and then the second equation balances out to 1 equals 1. So now that I've checked my answer, I know for sure that the solution to this system is 1, 3, which means x is 1 and y is 3. So your job for today is to take down notes. So I hope you redo this example with me. If you have color pens or color pencils, that would work better. And then make sure that you write a summary.